how do we compose functions? Um, when we talk about composing functions, this is the idea of putting one function into another function, something like g of f of x. And we're also going to introduce in this video a different notation. Instead of writing it this way, there's another way that mathematicians frequently write it. So the big hint is to work inside out. The two steps for composing a function problem is to rewrite the function definition with a blank representing the variables. And then substitute whatever the input is into the blank. So if we have something with these two functions, we're going to use these functions over and over, and we're simplifying f of 7. So let's write the function with a blank where it goes, and then we put in our input in there. This is something that we've done many times. 21 plus 2, 23. Now, what if it says f of y? Well, we're going to do the same thing. We'll do 3 blank plus 2. You should always use parentheses and then substitute your input in there. And then we get 3y plus 2. What if we have y squared? Exact same thing. 3 blank plus 2. Even though it's y squared, we're not squaring anything but the input. We get 3y squared plus 2. If we start talking about this, well, now we have multiple ways of doing this, but we're going to go with the easiest way. We have f of g of 7. G of 7 is 8 minus the blank, and that blank is 7. Then what we can do here, which is why this is easier than the other way, is we simplify this. We get f of 1, and then we can do 3 blank plus 2. I'm going back to this definition every time. 1, so 3 plus 2 is 5. That's all well and good. It becomes a little more complicated when we start doing f of g of x. So we take f of g of x, we know is 8 minus x. Now what we want to do is we want to write the outer function, 3 blank plus 2, and we're going to take the inner function and substitute it in. So all of 8 minus x gets substituted in where x is. And that's the trick. It's important to leave the parentheses there, and hopefully this is your view. And then we distribute, but the key thing is to bring that whole 8 minus x and put it in to that blank. Now, a new notation that we haven't used very often is GOF. And that O isn't actually an O, but it's a small circle that's supposed to represent composition. Just like we have, say, GF represents G times F, GOF. Some people do pronounce this GOF, but that's not a technical definition. This is just saying this is a function that takes in an input, runs it through f, and then takes the output of f and runs it through g. The other way of writing this is g of f of x. This is identical to GOF, and if you write this every time that you see GOF, you're fine. So let's take this f of x, 3x plus 2, and put it in to our function g. So let's write the function g with a blank wherever x used to be. Now, this is a function where there's only one blank because x only appears once. But if x appears more than once, you want to make sure that you put a blank in every time that x appeared in the original function. I've changed the functions around, so let's say if we have f of g of something, here what this would look like would be, let's see, the outer function is the f, so 3, and then inside we're going to take g, and that's going to be going inside the blank of f of x. So 5 times the natural log of x goes there. We have been asked to square this, so this becomes 3 times 5 squared plus natural log of x squared. This all becomes 75 times natural log of x squared, and this cannot be simplified any further. That was the same question, wasn't it? Now, if we want to go the other way, we say g of f of x, goth, is, take g, f of x is 3x squared, and then g is 5 times the natural log of blank, and that blank is 3x squared. Some people, I've seen them do like 5 times natural log of x and then put next to it 3x squared. No, this input has to go in wherever x used to be in our outer function. And this is not going to go any further, so that's all set. One thing that I forgot to pre-plan was if we have g of x equals, say, something like x squared plus 2x, and we're substituting in something like x plus h, we need to make sure that that gets substituted in every place. So our original function is blank squared plus 2 times the blank. Now this x plus h is going in for each blank. So we have x plus h squared plus 2 times x plus h. So please make sure that you do that if you have the input showing up multiple times in the definition of your outer function. That's it. Thank you.